How do you handle concept drift in pattern recognition? Imagine you're trying to teach a machine to recognize faces, but over time, people's styles change or new fashion trends emerge. How do you keep the machine accurate when the patterns it learned no longer match what it sees? That's where handling concept drift comes into play. Concept drift happens when the relationship between the data the machine sees and the output it predicts changes over time. This can cause the pattern recognition system to become less reliable because the old patterns no longer fit the new data. To keep these systems working well, we need to detect when this change occurs and adapt quickly. The first step is to watch the system's performance constantly. If error rates start to rise or the data looks different from what the model was trained on, that's a sign of drift. Tools like drift detection method and adaptive windowing help by tracking errors or shifts in data patterns over time. They alert us when the data no longer matches the original patterns. Next, it's important to understand what kind of drift is happening. Sometimes the change is sudden, like a new trend appearing overnight. Other times, it's slow and gradual, like a shift in customer preferences over months. Recognizing this helps decide how to respond. Sudden drift might need a quick retraining, while gradual drift can be managed with ongoing updates. Once we know the type of drift, we can adapt the model. One way is to retrain the model using the most recent data, so it learns the new patterns. Online learning is another approach, where the model updates itself incrementally as new data arrives. Ensemble methods combine multiple models trained on different data segments, making the system more flexible. Windowing techniques focus only on the latest data within a sliding window, keeping the model current without retraining from scratch. After making these adjustments, it's essential to validate the model's performance on new data. Continuous monitoring ensures the system stays accurate and reliable. For example, in image recognition systems used in creative tools or streaming data analysis, handling concept drift means the system can adapt to changing styles or content over time. Ethically, managing concept drift is vital because outdated models can produce biased or incorrect results, which can harm user trust. Updating models responsibly ensures fairness and accuracy in AI applications. In short, handling concept drift involves detecting when the data relationships change, understanding the type of change, updating the model through retraining or online learning, and keeping a close eye on performance. This process helps AI systems stay effective and trustworthy as the world around them evolves.